Hello, here is a small tutorial explaining how to use a singular element and modify its parameters in order to integrate it into a network. In the library, you have a list of singular elements in the singular elements folder. And among these singular elements, there are elements whose parameters we can modify. For example, here, we are going to take, in the packing grids, a packing of grains of constant diameters, and we are going to use it to create a sand filter by dimensioning the diameter of the grains of sand. The first thing to do is to edit this singular element, and we will modify its parameters to create a new element, which we will save for our project. So, one of the first things to do is to determine its entry diameter. Let's imagine that here the inlet diameter is not 1000 millimeters, but 2000. This is a filter with a diameter of 2000 millimeters. So if the filter is not circular and square, we will use an equivalent diameter to obtain a section. As a reminder, the equivalent diameter, we will find it using the equivalent diameter tool. Here, we return its length to the width, and we will take the equivalent diameter given to us here. For example, a grid of 100 by 100 will have a diameter of 109. So we enter the diameter of the filter or its equivalent diameter. Let's say that this sand filter is about 1 meter long. We will therefore set the length to 1000 millimeters. And we will set the editable parameters. So for the record, it's a filter that was taken from the reference library IdleKick, which really provides a mass of information on a lot of elements. To see what the parameters correspond to, we can click on the image to enlarge it. And so we see the parameters appear a little more clearly. So we have a list of 4 parameters. T outlet, T inlet, is for entering a possible temperature difference between the inlet and the outlet. We say that the temperature is constant. It is a parameter for gases, with volume modification by temperature. Theta dig, it is the positioning of the particles if they are more or less packed. If they are packed, we will have an angle that will be quite open. If they are not packed much, it will be quite closed. This angle varies between 60 and 90 degrees. We will say that the passage is average, we will leave it at 75 degrees. The dg parameter in millimeters is the diameter of the grains in millimeters. So there, 30 millimeters is very large grains. For a sand filter, we will say that it is 3 millimeters grains. So here we have set the parameters of our new sand filter. We will call it sand filter so as not to modify our basic element, sand filter, and we indicate its diameter, 2000 millimeters. And dg, 3 millimeters. All we have to do now is register it. File, save. We close the element editor. And we create our network with this sand filter, who is called sand filter 2000 dg, which is in the singular elements. We'll start with a 100 millimeters conduit element. So we create a 100 millimeters conduit. Save it. it already exists, we'll cancel and use the existing one. We drag it into the interface to open a new network. And we flatten it. So think about the trick when you walk around the network. Press the space key to make the selection off in order to be able to walk around without changing the orientations. Otherwise, it's a bit of a pain. We validate. Here, we made a conduit of 1 meter by 100 millimeters. Now we will connect our sand filter to this element. Our sand filter here, but it has a diameter of 2000. So we have to widen it to get to this 2000 diameter. I select my pipe and use the widen function to go to 2000 millimeters. With a sudden widening, insert, and that's it. A little length to see clearly, we're going to say that it's 3 meters. So we're going to say that our filter is in the middle of a large tube. We're going to extend the widening with a piece of tube. Otherwise the model will be piled up in the same volume. It's gonna be hard to see. So we select our enlargement, and we continue afterwards. And there, we will put a piece of tube of 3 meters. So there, it would require a slightly larger grid for this kind of project. So we're going to cancel. We're going to resize the grid a bit, because it is less than the length of the object. So in the parameters, space, grids, we will go to 5 meters. So you have to apply the 5-meter grid with constant space, otherwise the grid will be resized according to the selected object. And there, so I continue after. And there, it's going to be easy because the grid is adapted. And there, now that I have a piece of pipe 1000 in diameter, I can insert my sand filter. Who's here? Just drag and drop it onto the selected conduit. And here is the sand filter which is placed at the end. I continue after the filter. That's enough. And so there, I can shrink afterwards and go back to 100 millimeters. I insert an abrupt and continuous narrowing with a conduit. Here we zoom a little, roulette, to move around. Just select an item in the tree and double-click on it. This recenters us on the end of the element. Here I will lengthen a meter and move to 3 meters to see better. So that's how we created our little system with a sand filter. We check the circulating fluid, it's glycol. I would like to put water. And there, we therefore used water at 10 degrees. And now we are going to test the speed. We will therefore see the possibility of testing the speed here. We will try with 200 cubic meters. To apply. Therefore, we force a flow rate of 200 cubic meters per hour. Here is the system, with a pump that provides sufficient pressure. To cross the filter at the imposed flow rate of 200 cubic meters per hour. And so we see the necessary pressure. There, it would take 8 meters of fluid column. If I select my pump and go to the detailed results, I will display the pressure in bar, 0.8 bars. To circulate the fluid at 200 cubic meters per hour in the sand filter. Here it was a small tutorial to explain how to use an element of the library and to configure it. Here we have configured and manufactured a sand filter. We can look at the pressure drop in pascals, which would be 856 pascals.